In the beginning, Earth was chaos. A restless planet cloaked in fire and storm. Lightning flashed across dark skies, raining energy into oceans thick with minerals. There was no air to breathe, no land to stand on. Only a boiling laboratory of chemistry. Within that violent sea, atoms collided endlessly. Carbon met hydrogen, nitrogen met oxygen, the universe's simplest ingredients mixing in countless ways. And somewhere in that molecular storm, something extraordinary began. Molecules linked together to form longer chains, each more complex than the last. Some could store energy, others could replicate their shapes. The oceans had become a chemical symphony, each note testing the boundaries between chaos and order. Then came a miracle of structure. Tiny bubbles of fat lipids formed in the water, trapping molecules inside. These fragile spheres were protocells, the ancestors of all living things. Inside them, chemical reactions began to repeat, sustain, and adapt. It was the universe's first experiment in memory, and for the first time, matter had learned to behave like life. No divine spark, no sudden magic, just the quiet persistence of chemistry searching for balance. From this union of chance and time, the first builders of life emerged, and the long dawn of biology had begun. For hundreds of millions of years, Earth was ruled by silence. No forests, no animals, no color, only a world of microbes drifting beneath an alien sky. These tiny pioneers were the architects of everything to come. They fed on heat and minerals, thrived in acid and ice, and endured cataclysms that would erase any larger creature. When asteroids struck and volcanoes tore the planet open, they waited, hidden in the darkness. And when the fire faded, they began again. Life had proven one thing: it could not be killed. Over time, these microscopic survivors began to change. They traded molecules, learned to share energy, and built the first biological networks. In this invisible world, evolution was quietly at work, selecting, shaping, perfecting. Eventually, one lineage emerged that would connect them all. Scientists call it LUCA, the last universal common ancestor. Every plant, every animal, every human can trace their family line back to this single microbe. It wasn't complex. It didn't think, or move, or dream, but LUCA carried the universal code of life, the genetic blueprint that would one day sing through every living thing. For over 1 billion years, life remained microscopic, patient, and persistent, waiting for its chance to grow. The long night of evolution would soon end, and with the coming of light, life would learn to breathe. evolution began. Some microbes discovered a new way to survive. Instead of feeding on minerals or heat, they turned to light. They learned to capture energy directly from the sun, transforming sunlight, water, and carbon dioxide into food and fuel. It was one of nature's greatest inventions, photosynthesis. With each reaction, these tiny architects released a waste product no one had ever seen before: oxygen. At first, it was poison. Oxygen corroded metals, burned organic matter, and killed many ancient species that could not adapt. But for a few, this new gas became power. Oxygen reshaped the planet. It reacted with iron in the oceans, turning the seas from dark green to vivid blue. It rose into the sky and formed a protective ozone layer, shielding the surface from deadly radiation. And slowly, the air became breathable. For the first time, the Earth exhaled. The event was catastrophic and miraculous. All at once, a global extinction that birthed new life. Scientists call it the Great Oxygenation Event. It changed everything: the chemistry of oceans, the color of skies, and the destiny of life itself. From this invisible transformation came the energy that would one day fuel movement, thought, and consciousness. What began as a simple reaction in ancient seas became the rhythm of every breath we take. Even now, each inhale carries the memory of that ancient dawn when Earth, at last, learned to breathe. For billions of years, life had survived as single cells, simple, efficient, but limited. Each cell lived and died alone, a tiny island drifting in the endless ocean of time. Then, something unexpected happened. A single act of cooperation changed everything. One cell swallowed another, but instead of being digested, the smaller cell began to live inside the larger one, a partnership, not a meal. This was endosymbiosis, a turning point in the history of life. Inside its host, the smaller cell produced energy. In return, it was protected and fed. Over time, they became inseparable, two lives merging into one. The energy-producing partner evolved into what we now call mitochondria, the power stations of every complex cell. Later, another partnership formed a cell, captured a photosynthetic bacterium, and it became the ancestor of chloroplasts, the green engines of plants. For the first time, life discovered teamwork. It was no longer survival through isolation, but through collaboration. This innovation allowed cells to grow larger, to specialize, and to communicate. It unlocked new possibilities, the foundation for tissues, organs, and entire bodies. What began as a single act of coexistence became the blueprint for complexity itself. From this moment, evolution had a new tool: unity, and life, for the first time, began to imagine what it could become. Through tiny chemical signals, they learn to sense each other, to cooperate, to act as one. At first, These alliances were fragile, temporary unions formed to share food or defend against danger. But nature was experimenting, and one day, the experiment succeeded. Some cells stayed together after dividing. They specialized, each taking a different role. Some gathered nutrients, others sensed the environment, and some took charge of movement. This was the birth of multicellularity, a concept so simple, yet so revolutionary. Now, life could grow in size and imagination. Creatures formed bodies made of billions of cooperating cells, each one alive, yet part of something greater. With cooperation came innovation. New forms appeared: filaments that waved through water, colonies that moved toward light, organisms that could crawl, swim, and hunt. The world, once ruled by chemistry, was now ruled by biology. Each generation built upon the last, refining eyes that could see, membranes that could feel, and networks that could think. Complexity had become evolutions, new language, a spiral rising from the simplest of beginnings. And as life's structures grew more intricate, so too did its awareness. From clusters of cells came nerves, from nerves came thoughts, and from thoughts came curiosity. It all began here, in the silent oceans of early Earth, where chemistry first became cooperation, and cooperation became consciousness. This was not the end of creation. It was its true beginning.